Hello, welcome to all to our channel Next Gen Engineering and Technology. Before starting today's video, we would like to sincerely thank to all our subscribers and for increased views. So keep supporting us. Thank you, sincerely thanking all of you. So today we are going to discuss about we are continuing discussing about structural analysis and type of supports, their reactions, statically determinant and indeterminate structure, and degree of freedom. Let's start. So just a quick recap of previous videos. There we have learned that sum of the forces in the direction of x-axis, that is summation fx, will always be 0. Sum of the forces in the direction of y-axis, summation of fy, will always be 0. Sum of the forces in the direction of z-axis, fz, will always be 0. Who has not seen the previous video yet, we'll put it in the card so you can click it and watch the entire video to understand this. We'll just have a quick recap. We will not explain anything which was discussed in the previous video. And similarly, sum of the moments forces about x-axis will be 0. Sum of mx, sum of the moments of the forces about y-axis, sum of my will always be 0. Sum of the moment of the forces about z-axis will always be 0. Now coming to the support, we are mostly discussing three types of supports: hinge support, roller support, and fixed support. Hinge support, you can see, so there are two restraints, so the reaction will be 2. Roller support, this support can move freely in this direction. It will resist a movement in this direction, so the support reaction will be 1. A fixed support, it will resist 3 ways, in vertical, horizontal, as well as a moment will be created, so the number of reaction will be 3. So again, a quick recap of the formula to determine statically determinate structure and indeterminate structure. So just briefly discuss once again what is statically determinate and what is indeterminate. When the equations of equilibrium are sufficient to determine the forces and stresses in a structure, we say that this structure is statically determinate. A structure for which the external reactions component forces cannot be calculated using only equilibrium statically, they are called statically indeterminate. So what is the formula? M plus R equal to 2 multiplied by N, or also you can say M plus R minus 2 multiplied by N equal to 0. For simplicity, let's consider that M plus R equal to 2 multiplied by N, where M is the number of members, R support reactions, N number of joints or nodes. So number of member plus number of reaction shall be equal to 2 times of number of joints or node. So then we can call the frame is statically determinate. I hope this is clear. So let's proceed to the next slide. So here M plus R equal to 2 multiplied by N, that we have seen. So now we can write the equation like this: M plus R minus 2 multiplied by N equal to 0. So this is also a satisfying condition for statically determinate frame. Now if we do not get the result as 0, we call the structure is statically indeterminate. So that means M plus R minus 2 multiplied by N will not be equal to 0. So that will give a figure like 1 2 or something like that. So the figure, that is member plus reaction minus 2 multiplied by the nodes, equal to say 1. So we'll call that 1 is as degree of indeterminacy, which is denoted by ID. So the formula for ID is ID equal to M plus R minus 2 multiplied by N. I hope this is very much clear. So M plus R, member plus reaction minus 2 into nodes, will be 0. If this equation is satisfied, then that frame will be called statically determinate. If this equation is not satisfied and this is not equal to 0 and there will be a figure, a number, then it is statically indeterminate beam, and the number is called ID, that is degree of indeterminacy. These two equations are very much important. You can just write it down and or memorize. And now we'll go through some examples to get the clear idea, as well as these if you practice these examples, then entire idea will be very much clear. So this is our frame. So you just here what are the number of members? 1 2 3. So number of members M equal to 3. Here this is a hinge support, so number of reaction will be 2. This is a roller support, so this direction there will not be any reactions, only vertical VC there will be a reaction, so 1. So total number of reactions is equal to 3. What are the number of joints? 1 2 3. So number of joints N equal to 3. Now M plus R equal to 2N. We need to see that this is getting satisfied or not. So number of members 3, number of reactions 3, equal to 6. So node is 3, 2 multiplied by 3 equal to 3. So M plus R minus 2 multiplied by N equal to 6 minus 6 equal to 0. So we can say this is a statically determinate frame. I hope example A is clear. Now Let's check for another example. So this is another frame. Here one hinge support, and we have seen another support. This is a roller support. So let's consider the support reaction for hinge support, that is 2. That is for roller support, that will be only one reaction. This reaction, it will move freely, so it is 1. The reaction is 1, so total support reaction is 3. Now let's count the number of members. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So number of members m equal to 11. Now now count the number of nodes. 1, 2, 3, 4, 5, 6, 7. So node is 7. So hence m plus r equal to 14. 11 plus 3, 2 into 7 is also 14. So 14 equal to 14, or 14 minus 14 equal to 0. So this frame is also statically determinant. I hope this example is also clear to all of you. Now let's move into a bit complicated structure. So here again there is one hinge support and one roller support. So the number of reaction is obviously 3. Now you please count the number of members. 1, 2, 3, 4, 5, 6, 7, 8, 9. There is no node here. So 8, 9, 10, 11, 12, 13, 14. So number of members is 14, number of reaction is 3. So total m plus r equal to 70. Now number of nodes we need to count. 1, 2, 3, 4, 5, 6, 7, 8. So total number of nodes are 8. So 2 into 8 equal to 16. So m plus r minus 2 into n equal to 17 minus 16 equal to 1. So we are not getting the result, that's m plus r minus 2 multiplied by n equal to 0. So first condition is not satisfying. So this structure is statically indeterminate. So number of unknown cannot be calculated by the equations in hand we have. So the result is m plus r equal to 17, 2 multiplied by node number is 16, so 1. So now we have learned that degree of indeterminacy id is m plus e minus 2n, so the degree of indeterminacy is 1. So first condition it is not satisfying, so this is statically indeterminate frame and the degree of indeterminacy is 1. Now move on to the next thing. So this is also another structure. If you just count the members, you'll get the number of members for 15. Number of reactions will count here. This is a hinge support. This is another hinge support, and this is also a hinge support. So 3 number of hinge support. So we will get the reaction is 6. Number of nodes are 8, and the number of members are 15. So id is m plus r minus 2 into n. So 15 plus 6 is 21 minus 16. So total degree of indeterminacy is 5. So this structure again, this is statically indeterminate structure and degree of indeterminacy is 5. So let's move on. I hope this example D is correct. I am not just counting member by member. You can pause the video and just count. Thank you. Now we'll introduce to another concept that is called degree of freedom. So we hope statically determinate frame, support reactions and degree of indeterminacy is clear. We would like to introduce the concept of degree of freedom. What is degree of freedom or DOF? Degree of freedom is defined as a set of independent displacement stroke rotations that describe the deformed shape of the structure with respect to its initial position. So let's simplify it. In simplest term, DOF of the structure is the number of directions the structure can be moved freely without any restraint. Before moving to the slide, you just concentrate in these two lines. In simple terms, DOF of the structure is the number of directions the structure can be moved freely without any restraint. So let's consider a hinge support. So you know a hinge support generates two reactions, one vertical, one horizontal. So it allows a member to move freely in one direction. So the degree of freedom of a hinge support will be 1. Similarly, we know a roller support, it allows the structure to move freely in this direction. It only resists a structure to move in this direction, but again it will allow the structure to move in this direction. So degree of freedom for a roller support will be 2. So now coming to the table and the figure we tried to explain. So this is a hinge support. So you know a hinge, it will not allow to move in this direction, this member, and hinge support will not allow to move in this direction, but it will allow to move a member in this direction, like this. So the degree of freedom will be 1. So cases will be 3. This direction one movement is possible, this direction one movement is possible, this direction one movement is possible. So total possible movement is 3. Now this hinge support is resisting the movement in 2 direction. This direction movement is not possible, this direction movement is not possible for a hinge support, and this direction only movement is possible. So total possibility of movement was 3, but hinge support is restricting movement in 2 directions, that is R2. So the degree of freedom or DOF is equal to 1. Similarly, this is a roller support. It is allowing this direction a movement, it is allowing this direction a movement, but it is restricting movement in this direction. So possibility was 3, but resistance is 1, so degree of freedom is 2. I hope this is clear. We'll come to rocker and link on a later stage in a detailed video. So let's come to the fixed. It is totally fixed and it is not allowing movement in any direction, so degree of freedom is 0. So this table I hope is clear. Degree of freedom for fixed is 0, degree of freedom for roller is 2, degree of freedom for pin on hinge is 1. So this is the same thing we have, instead of table we have elaborated vertical direction and horizontal in vertical direction and in horizontal direction hinge support is resisting, so therefore degree of freedom is 1. And for roller support only vertical direction it is resisting, so degree of freedom is 2. Vertical, horizontal and rotation all where it is fixed support is resisting the movement, so degree of freedom is 0. So now we'll calculate our degree of freedom and statical indeterminacy for this structure. So just before now how to we were talking about in this previous video, previous slides, the degree of freedom for particular support condition like roller or hinge or fixed. Now if we want to calculate a frame's degree of freedom, how to calculate it? So first we'll again go back to the our previous formula to calculate it is statically determinant or indeterminate. So let's start. The number of members is 12. 1 2 3 4 5 6 7 8 9 10 11 12. So number of members 12. Number of reaction, both are hinge support, so 2 plus 2 4. Number of nodes 1 2 3 4 5 6 7, very easy. So number of nodes are 7. So degree of indeterminacy is m plus or minus 2 into n. So m was 12 plus 4 16, 2 into 7 is 2, that is 14. So we can say this is a statically indeterminate structure and degree of indeterminacy is 2. Up to this point we have already calculated 3-4 examples we have calculated. I hope this is lucid for you, all of you. Now degree of freedom, number of member minus degree of indeterminacy is will give you the degree of freedom for a particular frame. So 12 minus 2, so degree of freedom will be 10 here in this particular case. So I hope this is clear. I am repeating this part once again. Degree of freedom, the formula for degree of freedom is number of members minus static degree of indeterminacy. So degree of freedom is number of member was 12. We calculated that ID is 2, that is degree of indeterminacy. 12 minus 2 equal to 10. So the degree of freedom for this particular frame is 10. So this is another frame we have given. We will explain it in our next video. So meanwhile, if you just calculate on your own and put your result in your comment box, that would be very much helpful and exciting for us. So looking forward for your results, and we hope this video was helpful and you understood the concept. These are very important concept, and we don't generally we don't find this concept discussed in very much detail. So we are concentrating on this. In our next videos we will discuss about the load disbursement, and then we will move to bending moment and shear force diagram. So hope to see you again in our next videos. Thank you, and like, share, subscribe. We are grateful for all the subscribers. We hope it will be the videos will be shared and liked by all of you, that we can get more subscribers. That will be helpful, and that would help us grow and motivate to make this kind of videos more and more. And take care. Thank you.